Hi, everyone. The music's down, so I guess that means we're supposed to start talking. My name's Harry Pearson. I'm on the Windows Runtime Experience team.
And my name's Jesse Kaplan. I'm on the Common Language Runtime team in the .NET Framework.
And we're here today to talk to you about using the Windows Runtime from C# and Visual Basic. Do we have any C# or Visual Basic developers in the house? Yeah, okay. So, well, one F#. See, he said he was going to say anything. Troublemaker. Okay. So, let's start with a little bit of context, okay? Windows has a very rich history of providing great capabilities for application developers to build on. Right, we saw some of this yesterday in the keynote and the big picture sessions. App settings that you set and forget and automatically roam between a user's devices via the cloud. Sensors that tell you where a user is and how they're holding their device. App-to-app integration that lets you integrate tightly into the Windows experience for things like share and search and file picking. Access to the webcam, that now ubiquitous piece of hardware that seemingly every mobile device being manufactured today has. Windows has a great tradition, and Windows 8 continues that fantastic tradition of application capabilities. What Windows doesn't have a particularly great history of is making it easy for you, the managed developer, to access those capabilities. Has anybody here ever actually tried to write C# code that accesses the webcam? A couple of people, right? Straightforward, that's not the word I would use to describe this code. It's hard, right? P-invoke, com-interop, rocket science. Now, the reason why you have to do this previously is because of the fact that there's a gap between the code that you write in managed languages like C# and VB and the underlying capabilities exposed by Windows APIs. Windows has traditionally exposed APIs in two ways: flat C-based APIs and COM-based APIs, neither of which are directly consumable by the CLR. What you need to do is somebody has to build a bunch of manually has to build a bunch of code to fill that gap. Now, maybe that's the base class library team. Maybe that's some open source project. Maybe some intrepid member of the community has recorded the magical incantations up on pinvoke.net so you can copy and paste them into your project. Or maybe you're stuck groveling Windows header files trying to figure that stuff out yourself. How wide is a D word again? This is obviously not a tradition that Windows wants to bring forward. And Windows 8, this is not the kind of problem you have anymore. We saw this code yesterday in Alesh's big picture talk. This is the code that you write. We're going to see this code run live on stage in a few minutes. And because I'm not a manager, it won't screw up. I hope. Yeah, famous last words. So this is the code you write to capture a picture with the webcam and put it in your XAML-based UI. It's less than 10 lines of code. There's no p-invoke, there's no rocket science, there's no black magic, there's no voodoo, there's no com-interop. Just good old-fashioned, natural and familiar C# the way you're used to writing. In fact, the only reason you would even know this code is anything other than just some old managed library is because we have this using statement at the top. Using windows.media.capture. You haven't seen that before this conference. We're exposing native Windows capabilities directly to you, the managed developer, in a natural and familiar way. We can do this because of the Windows Runtime. If you were one of the privileged few who was able to actually cram into Martin Lovell's session in the previous hour, he showed you this slide. And if you weren't, it'll be available on video by tomorrow, so check that out. We're talking about the Windows Runtime. Typically, when we talk about the Windows Runtime, we think of it as the API surface area of Windows 8 that's available for Metro-style apps. But on the Windows Runtime team, we think of it as the infrastructure that we use that allows APIs for Windows to be projected into these different languages, into C++, into JavaScript, and of course, what we're all here to talk about today, into C# and Visual Basic. I've been asked to point out, by the way, that just because we have the Windows runtime doesn't mean that things like the common language runtime have gone away. Right? There seems to be a small amount of confusion about that. When you're building managed applications, you're still running this stuff on top of the CLR. You'll see it up there in the upper right-hand corner. It's still part of the story for building managed applications. We'll talk a little bit more about that as we go through.
It's not just the CLR, too.
It's not just the CLR.
VCL and the .NET framework.
Sure, you're right. Absolutely correct.
Yes.
Thank you for, go figure, the guy from the .NET team wants to correct me about the .NET framework.
I work on the CLR itself, but there are people here who work on the higher library, so
Yeah.
I want to make sure they get a call out.
Good point, good point. Thanks very much, Jesse. So I like to think of this as automatically filling that gap for you, right? You get to write the code you want, and Windows takes care of the plumbing to wire up these APIs that you're using directly into the native system APIs that are exposed by Windows 8. No black magic, no voodoo, no rocket science. You get to spend your time focusing on a great app instead of building plumbing to let you talk to Windows. Now, I know there's been some concern in the managed development community over the course of the last few months. What exactly was the role of managed code going to be in the Windows 8 developer ecosystem? I hope that between the keynote yesterday, between the big picture sessions from yesterday, between this talk and other talks like it at this conference, you understand that C# and Visual Basic are first-class citizens of the Windows developer experience. They've been a part of the Windows developer vision from day one. That means you guys already know how to do this. Sure, there's going to be new APIs to learn. There's always going to be new APIs to learn, and Windows 8 has more than its fair share of new APIs to learn. But you know what you don't have to learn? You don't have to learn a new language with new keywords and new semantics, right? And a new application model. There are people in this room who have been working with .NET since it was originally introduced at PDC 2000. That hard-earned knowledge is as relevant today for building Windows 8 applications. It's arguably more relevant than it has ever been before. If you leave here thinking one thing, remembering one thing, I want you to remember this. You already know how to build Metro-style applications.
So are we done here, Harry?
Yeah, I think that's it, right?
There we go.
Okay, so have we set the context? Are we cool? Okay, so let's talk about how this rest of this talk is going to go. We're going to first start by talking about the relationship between .NET and the Windows runtime. It's been a little confusing out there on Twitter, so I want to just clear up a couple of things. Then we're going to both talk about and see how we use Windows runtime APIs from C# and Visual Basic. And then we're going to close out by actually building a component in C# and consuming it from JavaScript. Everybody saw Alessia's demo yesterday where they took a C++ component and consumed it from JavaScript. You guys can do that too with C#. So let's talk about the relationship. C# and Visual Basic were a key influence on the design of the Windows runtime. My team, the Windows runtime team, that's what we've been doing for the last 2 years, is building this infrastructure. And we knew how important it would be to make sure everybody in this room and all those other managed developers out there had a great experience building Metro-style applications. Now, if you were to go to Herb Sutter's talk, Herb will tell you that C++ was a key influence on the Windows runtime. And if you went to Luke Hoban's talk, Luke's from the browser programmability tools, the guys who build the Chakra JavaScript engine, he will tell you that JavaScript is a key influence on the Windows runtime. And we're all correct. Each of these different language environments contributed to the overall design of the Windows runtime. We're going to talk a little bit right now about the key contributions that .NET made to the overall design. So first off, Windows runtime is designed to be used from object-oriented programming languages, you know, like C# and VB. And you're probably thinking, duh, Captain Obvious, hello. But think about where we're coming from here with Windows runtime. Martin Lovell talked about in his talk about the fact that Windows runtime's foundation comes from COM. Right? COM is object-oriented, but it's not designed to be used from C# and VB. Right? Because COM isn't class-oriented, it's interface-oriented. And it's really hard to make that feel natural and familiar to a C# developer. So what we did is, as we built on that foundation, we added semantics to the underlying infrastructure that made things feel natural and familiar from C# and VB, like classes, like constructors, like statics, like events. We are able to make that gap that we had to bridge that much smaller by having an infrastructure that was that much closer to the environments that we were looking to project into. And as I mentioned earlier, the CLR is still there, right? This hasn't gone away. If you want to write a bunch of link code, guess what? That's all running on top of the CLR. All that stuff still works just as it does today. We're just providing new APIs via the Windows runtime for you to consume. Next up is metadata. Windows runtime includes rich machine-readable metadata for every single Windows runtime API on the system. This is not a developer SDK install thing. It's on every single Windows 8 machine. Now, that sounds kind of familiar, right? If we're managed developers here. Does that sound familiar to you, Jesse?
I think I've done this a few times before, yeah.
Of course, CLR does this. Every single managed assembly, DLL or XE, includes rich machine-readable metadata that describes the surface area of that specific component. We've taken this great idea from DevDiv, pushed it down into the platform so that all Windows developers can take advantage of it. And not only did we take the idea, we also took the implementation. We could have gone off and invented our own format and structure and all that kind of stuff, but we didn't. We used the same standard, Miguel, I said standard, I hope you were paying attention. Standard ECMA 335 CLI metadata format that the CLR uses in Windows runtime metadata. We did make a few minor upgrades to it, but as Jesse will tell you, it wasn't a lot of work. In fact, you know what? Let's see this in action. Jesse?
So in fact, it wasn't a lot of work. My team owns ILDASM along with a lot of other tools in addition to the CLR. And I think we spent about a day over the course of the last 2 years updating ILDASM to work on WinMD files.
A whole day? Does that include test time?
It's probably about an hour spread over 8 days. So what we're going to do now is we're going to find these metadata files that Harry swears to you are on this system. So we start in C drive, go to Windows. Now where's everything cool in Windows?
System 32.
System 32. And then you'll find the Win metadata directory. And inside of this, you see a whole bunch of assemblies, or sorry, WinMD files.
Yeah, they're not assemblies.
They're not assemblies. These actually only have the metadata because the implementation, of course, is
native. All of these Windows runtime APIs are native. They are all built in C++, but we are still describing them using the same metadata format that the CLR does. So you can open them in ILDASM. There's not going to be any IL, of course, but you can still see.
Oh, you stole my punchline.
Oh, I'm sorry.
I hadn't quite opened the window yet.
Oh, I'm sorry.
So,
they already said it. They talked about it in Martin. Well, nobody saw it because nobody could get into Martin's talk.
Half the audience saw it because the room is half the size.
Oh, there you go.
Anyways, this is the metadata file for some of the APIs that we're going to be discussing later. And you can see that it looks, at the very beginning, like a normal .NET Framework metadata assembly. Now, these are the types. You see the camera capture UI type. It's got a constructor. It's got an async method. It's got properties. It's got settings. It implements a bunch of interfaces, just like normal .NET Framework types implement a bunch of interfaces. If you look in deeper, you'll find no IL, of course. But again, if you look at the .NET Framework reference assemblies, which are the closest analogy to these, you won't find any IL in those either. So this is very, very familiar to .NET developers, and it really is a metadata system that very, very closely matches the .NET Framework's metadata system. The format's the same. The definition in a few places is a little different. But from C# and VB, you're not going to be able to tell the difference.
So that rich metadata, that rich ecosystem of CLI metadata tools can be able to read and write these files with a minimum amount of upgrade and change.
Guess what? FXCOP already runs on top of these things. FXCOP's used internally to help us make sure that these follow the guidelines we want them to.
No, now you're giving away as part of my talk.
Ah, fair play, fair play.
Yeah. Okay, so we talked about type system, we talked about metadata. Let's talk about XAML. There are lots and lots of talks about XAML at this conference, so we're not going to go into a lot of details, but if you've been doing WPF or Silverlight development over the course of the last few years, we have a stack for doing user interfaces in Metro-style apps for you. The namespaces, you saw that fantastic demo yesterday. We pulled down a Silverlight application, made a few minor changes, primarily to namespaces, got it running on Windows Runtime, made a few more minor changes, got it running on Windows Phone. The same UI stack between Windows Phone and on Windows 8 for building Metro-style applications. We're not going to talk about it much more here, but I just wanted to point out, obviously, a key design influence that came from .NET. And speaking of jumping ahead, Jesse, on Friday, my teammate, Brent Rector, is here to do a talk. Brent Rector was he ran the Windows API Review Board. You may be thinking to yourself, I didn't know that Windows had an API Review Board. What have those guys been doing all these years? Well, we didn't. I don't know if it was obvious. But we do now. And this is, again, one of those things that we really learned from the CLR and the .NET team. Those guys have had an API Review Board since day one, or since version 1. In fact, Christoph, who wrote the .NET design guidelines, also sits on the Windows Runtime API design board, along with other folks from inside of Windows and some of the other language projections. And again, it isn't just the concept. Many of those design guidelines that Christoph wrote have been copied and pasted into the Windows Runtime API review design guidelines. Not exactly, as I mentioned, we've gotten contributions from C++ and from JavaScript, so it's not a one-to-one mapping, but many of them are just cut and paste, copied over. And when you see the way the namespaces work, go figure, that's pretty much just like .NET. The naming, the way that naming is done, just like .NET. It's part of the reason why it feels so natural and familiar to you as a .NET developer when we look at this code. So type system, metadata, API review, XAML. It's not an accident that this stuff works so well together. We designed it that way. We designed the Windows Runtime to feel natural and familiar from C# and VB from day one. That's the reason why you can barely tell that you're working against a native API instead of a traditional managed assembly when you use the Windows Runtime. In fact, you know what? Let's see it. Right? Let's start talking about using the Windows Runtime from C# and VB. Now, you've probably heard me use this phrase, natural and familiar. Right? It's a term that we used a lot in the Windows Runtime. It was sort of our mantra. Right? It was really, really important to make sure that we didn't have a compromise when developers used our system. Right? We did none of this p-invoke, com interop kind of stuff. We had to make it as natural as humanly possible. And so whenever we had a design decision, what's the natural and familiar way? That's the way we did it. Now, we could talk about this and look at 1,000 or 4,000 more slides, but what do you say we just see it run? OK, so I said we have XAML. Here we have XAML. This is the same XAML that you saw yesterday in Alessia's talk. It's not very complicated XAML. I am a type system plumber, not a UI design unicorn. So believe me, you do not want me doing any of your UI design. So we just have a button and an image. And we're going to come over here into our code. And we're going to fill in the click me event handler. And I'm going to write var UI. This is the same code we saw on the slides earlier, right? So if you watch, my hands never leave my arms. New camera capture UI. Not coming up in IntelliSense. It's because we haven't defined we haven't done the using statement for this namespace. So I'm going to use this great feature in Visual Studio. I think it was actually added in 2010, right?
2010.
To resolve the namespace. So I just say using Windows Media Capture, and the little red squiggly line goes away, and we start to get the right kind of highlighting. If we go up to the top, you'll see, look, I have some system namespaces like system and system link and system threading.tasks. Again, this is just the same old CLR that you've been using for years, same kind of stuff. And then here's all these Windows namespaces. Some of these are brought in by the template. Some of these are for later in the demo. And here's Windows Media Capture that got added when we used the resolve operation in Visual Studio. So now we'll come back down here and we'll say we want to make sure the user, we're going to set some properties just to sort of show that working. UI, now, by the way, you'll see IntelliSense is working now that I've done the resolution of the namespace. Again, this is all driven by that same Windows Runtime metadata files that we looked at in ILDASM earlier. I'm going to set the photo settings. I'm going to set the cropped aspect ratio to new size Okay, now I can't remember. Was it 16 by 9 or 4 by 3?
I think we're going to do 4 by 3 now.
Okay, 4 by 3. That's what it was on the slides. Okay, and now we're going to say var file equals, not new, await, my favorite new keyword in C#. Since the last new keyword in C#, dynamic, I have a special place in my heart for that one.
Did you used to work on dynamic technologies?
I did used to work on dynamic technologies. I still work on dynamic technologies. So I was here. What was I doing? UI dot capture file async, right? So this is an async operation. This is this great new feature, the ability to write these kind of asynchronous operations in a straightforward fashion. I'm going to pass in an enumeration. I want the user to only pick a photo, not to be able to pick a video. So I'm going to say photo, and that's that. And now I'm going to say if the user, because the user can choose not to actually take a picture. So I'm going to put this in an if block. I'm going to say var stream equals file, await. We're going to use this later in the demo, so this is diverging slightly from what you saw yesterday. File.open, and we're going to pass in read mode. And now we're going to say var bitmap equals new bitmap image. If you're a XAML developer, you'll probably recognize that before. Bitmap.setSource to the stream. And finally, photo.source equals bitmap. Okay, so less than 10 lines of code. Compile that. And that worked, so let's deploy it and run it.
I'm going to drive the camera here.
Yes. So, Harry's amazing UI. Actually, I stole it from John and Alesh, so it's their amazing UI. We're going to click the Click Me button. And, you've seen this before. We have to give it permission. I already set the capabilities to be able to use the webcam and microphone, so I'm just going to say allow. And there we go.
Who should I feature? I see a former manager of mine over there.
Okay, there we go. Okay, everybody smile. Okay, there we go.
All right.
So, now you see here, because I set the cropping, the UI, this component specifically now, forces me to make sure I pick an aspect ratio that matches. Right? And then I said OK, and there, now it's in the UI. Less than 10 lines of code, very simple. I know you guys aren't applauding because you saw this yesterday, so I've got a few more minutes of demo. Let's do something a little cooler. So we're going to come up here and use another cool feature of Visual Studio, DTM, Data Transfer Manager, also introduced in Visual Studio 2010. Data Transfer Manager is the object that implements the sharing contract. Everybody seen the sharing contract, right? So DTM dot get for current view. So here's a type with a static, right? The data transfer manager is a singleton, so we access it via a static method rather than by newing it up like we do for camera capture UI.
Stealing my thunder again.
Yeah. So now data requested. This is an event. You'll see it shows up with a little event icon. Now, how many times have we all done this? Plus equals, press tab to insert. Boom. So you can't really see it, but this is a typed event handler. This is a Windows Runtime type, which is what all the event handlers are used. And we hit tab again, and now we have the event handler for, I know what I've got. I've got the solution that's open. Sorry about that, guys. So you can see here the typed event handler, right? This is the event handler type for Windows Runtime. And now we have this main page data requested, which is what the event that gets fired when you actually say, I want to share. So what I'm going to do here is I'm going to actually pull this stream out of into class scope, or instance scope, and say I random access stream. This is a Windows Runtime type. We're going to talk more about streams later. No thunder stealing. All right. And now here we're going to say if stream equals null, args.request.fail with display text, no picture taken. So if you haven't taken a picture, nothing to share. Else, args.request.data.setBitmap, and pass in the stream. Okay, so we've now added a big 5 lines of code to make our application doubly cool. And it compiles. So, can you get a picture here for posterity? Okay, so I'm going to hit click me. Okay, everybody wave.
Mahesh, fix your hair.
Come on, wave. Oh, come on, you got to hold the camera still, dude.
Okay.
Okay, there we
Let
go.
it focus, not a video.
So we'll just take that picture. That looks good. Ted's looking off to the side. That's perfect. So now I'm going to come down here to the sharing contract. We've seen this before. Look, there's socialite. Takes a second. I'm going to say the coolest and most attractive audience at all of build, if I can spell, and hit share in Facebook. It takes a second, and to prove that there's no smoke and mirrors here, let's go to my Facebook page, and there it is, uploaded directly to Facebook. 15 lines of code, less actually than 15 lines of code. If you ask me, that's pretty natural and familiar. So Jesse, why don't you tell them a little bit more about what we just saw? I switched it.
There we go. So you can relax now. We're going to see this code and talk about it in a bit more detail rather than take your photos and make you famous. Mahesh, I know you like being famous. So, a few of the finer points of how Windows Runtime and .NET Framework work together to make this experience very good for the C# and VB developers. You'll notice the types have constructors with and without parameters. You can use .NET Framework primitives and pass those directly to Windows Runtime, just like you'd expect. There are properties, again, just like you see in the .NET Framework. Harry, add my line of sight. You can await .NET or Windows Runtime async operations just like you can .NET Framework ones. And again, they even come up with the async extension at the end, just like .NET Framework async APIs. There are statics. Thank you, Harry, for already telling them about that. And events as well. In fact, almost everything in the .NET Framework maps very directly to an equivalent concept in Windows Runtime. The constructs at the lowest level of the type system map very directly. If you look at any of these in ILDASM, you'll see that they're represented exactly the same way as they're represented in the .NET Framework metadata. Now, under the covers, as we said, the implementation's a bit different. But when you're writing C# and VB code, you don't have to care. You just use all of these things just like you normally would if you were calling a .NET Framework API. The only clue we saw that we weren't using Windows Runtime on that last slide was the using statements that talk about Windows dot. There are a few places where Windows Runtime types and .NET Framework types are a bit different. But in the vast majority of those cases, we've bridged the gap for you automatically, so that as a C# or VB developer, you don't have to care. You just write your code as you always would, and it works just like you'd expect. Now, Harry likes natural and familiar. I like just like you expect. And we discovered earlier, I think yesterday. Yeah. I think we discovered yesterday that Stephen agrees with me, so I think I win. So let's look at a few cases, just to give you a better context of what's happening under the covers. Let's give you a few cases of how the Windows Runtime and .NET Framework can be different, and how we bridge that gap for you. Now, Windows Runtime, just like COM, uses hresults to express error conditions. Well, in .NET, you don't like hresults. We like exceptions. And so when one of these failing hresults enters managed code, we automatically translate that to an exception. Now, if it's an hresult we know about, and one that maps naturally to a .NET Framework exception, we will throw that equivalent .NET Framework exception. So you will see file not found exceptions coming out of Windows Runtime. Now, there are some exceptions that we don't have a direct mapping for. So in those cases,
are those exceptions to the exceptions?
They are exceptions to the exceptions. You're just trying to get me to stutter, aren't you?
Yeah, just a little bit.
All right.
Oh, did you? Okay, sorry.
Yes. And just to, yeah.
Yeah.
Okay, so.
That was clear.
That was clear?
This is what you get for working close with somebody for 2 years, right?
Yes. So, when you call an async operation in C# or VB, you await it just like you do a normal .NET Framework task-based async operation. However, the return of this type, pick multiple files async, is not a task. You'll see it's actually a pick multiple files operation class. And if you looked at that more deeply in Visual Studio, you hit F12, you'll find,
I'm not standing.
You're not standing there now. You'll find that it implements an interface called iasync operation of T rather than task of T. It has no relation to task. However, the Windows Runtime interfaces have very similar concepts to the .NET Framework tasks. And so what we've done is in the framework and in the compilers is that allow you to await these Windows Runtime interface-based async operations just like you would await a .NET Framework task. So seeing that C# code, you had no idea that anything was different. And if you executed the application, you wouldn't be able to tell either. But under the covers, it is a bit different.
This seems like an audience that wants to dig under the covers.
I think so. Next, if you looked closely at that sample, you'll see the end result of that pick multiple files async operation is going to be a collection, in particular a iRead-only list of storage files. And you'll notice that this is in the System Collections generic namespace. This is a .NET Framework collection. It is not a Windows runtime vector, except it actually is. Under the covers, if you looked at this API using ILDASM, you would find that this method actually returns an instance of iVectorView in the Windows.Foundation namespace. However, for managed code, you see a normal .NET Framework iRead-only list type, not the Windows runtime type. And you can use it exactly like you can all .NET Framework collections. You can for each on it, you can use link, you can pass it to any .NET Framework APIs that operate on the .NET Framework collections. In fact, we have automatically mapped all of the core Windows runtime interfaces, collection interfaces, to their .NET Framework equivalents. You see a lot of things on this list that are familiar. You see iList of T, you see iEnumerable of T, you see iDictionary of key value pair. You see a few two new additions as well. iRead-only list and iRead-only dictionary haven't been here before. Well, Windows Runtime added the read-only version of collections, and for a while we considered just exposing them as is. But then in the forums, in the .NET Framework forums, there have been a lot of requests for read-only versions of our interfaces, so we went ahead and added them, and then we projected them to the Windows Runtime equivalent. Now, there were a few places where the difference between the Windows Runtime type and the .NET Framework type were just a bit too big for us to bridge the gap automatically. And so what we did in all of these cases is we added extension methods that make it very easy for you to convert to and from the .NET Framework and Windows Runtime version of a type.
Wait, you said all these places. How many of these places are there?
There are, in fact, 2.
So not all these, but I think both, right?
Both of these.
Both of these places. Let's
There
make
are
sure we
so
set the right
few that I'm going to show you the complete set of places where we have done this. The first of these are streams. In Windows Runtime, as you saw before, streams are interface-based. So you see iInput stream, iOutput stream, and iRandom access stream. Well, in the .NET Framework, we use the System.io stream class. And because the difference between classes and interfaces, we couldn't project one to the other. So what we did instead is we added this extension method, asStream. And with this extension method, you get back a System.io stream that you can use like any normal .NET Framework stream. You can pass it to any API in the framework that operates on System.io streams. Now, iInput stream is a very easy to use interface. You can use it directly in managed code. And if you want to call Windows Runtime APIs that operate on iInput stream, you don't have to do this. But if you do have .NET Framework stream APIs that you want to use, or .NET Framework APIs that operate on streams, you can call this extension method and go to town. And of course, there's the reverse as well.
Right, so that if you want to use, say, like that new HTTP client type, it gives back a stream, you can then call
as iInput stream.
As input stream, and then pass it into any Windows Runtime type, any Windows Runtime method that expects that type.
Exactly.
Cool.
Now, the other place we've done this was for an interface called iBuffer. Now, iBuffer is the Windows Runtime mechanism for efficiently passing around byte arrays. It turns out that this interface is very, very difficult to implement in managed code. And so what we've done is we've added an extension method so that you don't have to implement this interface. We have added an extension method to byte array that gives you back an instance of an iBuffer. And once you have this iBuffer, you can use it to call any Windows Runtime APIs that operate on an iBuffer. In this case, you're calling the protect async method, and you are encrypting this buffer. Well, now you've got an iBuffer back, but you actually want to use the encrypted byte array in your code. So what you do is you call the other extension method we added, try get underlying data, this time on top of iBuffer, and that will give you back a byte array that you can then use in your managed code. And so on the next line, you see us then passing this now encrypted byte array to a .NET Framework API that operates on the .NET Framework byte arrays rather than the Windows Runtime iBuffers. Pretty straightforward.
Yeah, so that's it, right? You've seen almost everything maps directly. There are a few places where things are different under the hood, but we bridge that gap for you. And there's only two, not all, but two places where you have extension methods that you can call to bridge the gap for streams and buffers between the managed world that you're used to and this new Windows Runtime environment.
That's right. Thank you.
So that's all these guys need to know to be able to actually write applications that use the Windows Runtime. Are we done?
We're not done quite yet. There were 3 items on your agenda. I think
true.
we've only hit 2 of those.
Yeah, so let's talk about actually building your own components in C# and VB.
Yes.
Jesse?
Thank you, Harry. So as we saw shown, it was very easy to call these APIs. Now, let's shift gears, and as Harry says, let's talk about writing Windows Runtime components in C# or Visual Basic. You already saw someone else demo how to create your Windows Runtime components in C++. Well, this is going to be a lot easier for this audience than that.
I think it's going to be a lot easier for everybody than that.
I wasn't going to say that. I had to let someone neutral say that.
Because Harry's so neutral.
I love all of the languages of the Windows Runtime equally, Ted.
Yes. So before we talk about how to build a Windows Runtime component, let's talk about when you should build a Windows Runtime component. Now, if you just want to build a reusable class library to use in your own applications, and you're using C# or Visual Basic everywhere, you don't need to write a Windows Runtime component. You can just create a normal .NET Framework class library and use it like you always did. It works just as you would expect. However, if you want to create a Windows Runtime component that's usable in JavaScript and C++, as well as C# and VB, then you will be building a Windows Runtime component. It's really to give you access to the full range of Windows Runtime languages. Now, in the old world, if you were writing managed code and you wanted to expose functionality to something other than managed code, you created a COM component. You had to learn a whole lot of stuff. You had to learn all about COM. You had to figure out, again, the magic incantation of attributes that got you where you wanted to go.
COM visible and public. That's my favorite.
COM visible and public. Try putting COM visible on a non-public type and see what happens.
Does that give you a compiler error?
It doesn't, actually. It won't do what you want at runtime, though. So you also have to learn about class interfaces, about COM default interfaces. You also, and we haven't even touched the marshalling code. I don't have enough room on this slide for that. In addition to that, you really have to think about your types and define your type systems differently. You have to think in terms of interfaces, because COM is all about interfaces, and it's really in your face. You have to design your APIs to be used as interfaces, not by classes. You can't do what you normally do when you create a managed class library. You can't just create a class and add some members and expose it. You have to learn about COM, and you have to learn about all this new way of thinking about things, or this old way of thinking about things.
Now, this is not natural and familiar.
It is definitely not natural and familiar.
It's not what you would expect.
I've owned interop for about 8 years, so it is now what I expect, but it is still not natural and familiar. This is how you do it for Windows Runtime. You create a class, you make it public, you add some public members, and you're done. Thank you. If I had shown the entire source code file, you wouldn't see any using statements that are any different from the normal .NET Framework using statements. This is a default class library project with some classes added to it and set to output a WinRT project, a WinMD file, rather than a DLL. So pretty straightforward. Now, the Windows Runtime type system is a simplified version of the .NET frameworks because it needs to support all of the Windows Runtime languages. So it supports C++ and JavaScript. So you don't have to learn any new rules. Or, sorry, you do have to learn some new rules. You don't have to learn any new concepts. You don't have to learn about COM. You don't have to know what's going on underneath the covers. But you do have to learn a few rules that make your components natural and familiar to C++ and JavaScript developers. There we go. First thing to remember is that these rules will only apply to the public types and members in your Windows Runtime component. You can add internal classes, internal members, private members, wherever you want. They're internal or private, so they're not exposed to Windows Runtime, and so they don't have to follow the Windows Runtime type system. You're free to go. It's only the public members and public types in your project that are exposed to Windows Runtime, so those are the only ones that have to follow these rules.
So that's that COM visible thing.
That's that COM. It's public, not COM visible. It's the way you do it in managed code, not the way you do it in COM. The first of these rules is that API signatures must only use Windows Runtime types. So these are types defined by Windows in the Windows Runtime, defined by you or other third parties who are creating Windows Runtime components. .NET Framework primitives that project directly to Windows runtime types, and .NET Framework higher level types like iList, IEnumerable, System URI that project to the Windows runtime equivalent. The next restriction is that structs in Windows runtime can only have public data fields. They can't have private fields, and they can't have methods. So when you're creating a Windows runtime struct in C# and VB, they can only have public data fields. Next, inheritance in Windows runtime is really just there, or should I say class inheritance, is really just there for XAML controls. So all other types that you define need to be sealed in order to be used in the full range of scenarios. And finally, we only support system-defined generic types. So you can use iList of T, event handler of T, typed event handler of T, but you can't define your own generic interfaces, and you can't have open generic types. That's not too bad. That's a few extra rules, but nothing strange. And as you build your project, if you strayed outside the boundaries, you're going to get compiler errors integrated into your project to tell you when you did something that wasn't quite fitting within Windows runtime. So there's no guesswork. There's no writing your code and finding out a day later that it doesn't work, or many days later that it doesn't work. You get an error right in the IDE, and it guides you on the right path. Now, I've said that these rules are pretty simple. Let's actually see a few examples of how these rules impact you when you are building Windows runtime components. The first type of thing you might do is you might create a managed class that wants to return a collection of integers back to its component. You might want to return a collection of something else too, but for our sake, let's use integers. Does anyone see a problem on this slide? Not my team. What was that? It should be an interface. List of T is not a Windows runtime type. Windows runtime uses interfaces for their collections. So if you had tried to type this in the compiler, you would have gotten a compiler error telling you list of int is not a valid Windows runtime type. It would have gone a step further, though. It actually would have told you, hey, it's not a Windows runtime type, but it implements these interfaces that are Windows runtime types. It implements iList of T, IEnumerable of T. Did you mean those instead? So the compiler really helps guide you and really makes sure that you are building a component that works well from all of the projections and makes it very easy for you. Another interesting case of how the Windows runtime type system impacts you as a C# and VB developer creating Windows runtime components is async. Now, when you create an async API in .NET, you tend to use await inside of your methods, and you return a task of T, and you mark your class async. Well, task of T is not a Windows runtime type. We saw earlier that Windows runtime async operations are based on an async operation of foo. And so what you need to do is you need to make this method private. Well, great. You can call Twitter. Problem solved. Your compiler's not complaining anymore, but you haven't actually done very much.
I don't think you fulfilled your story with this one. I'm just saying.
I think you're right. I think I need one more slide. Luckily, I did prepare for that. So in Windows runtime, as we said, you use iasync operation of string. So you add another method to your class library project, you make that one public, and then you use one of the factory classes that we've created to help you return an iasync operation of T, where in managed code you normally use the task of T. So just 2 extra lines of code to expose an async operation from .NET Framework, from C# or VB to JavaScript or C++. So very, very easy. And as I discussed throughout, Visual Studio has built-in support for managed Windows runtime components at every level. When you create a new class library project, you can change its output to be either DLL or WinMD. If it's DLL, it's a .NET class library. If it's WinMD, it's a Windows runtime component. And when you create a Windows runtime component in that dialog, you will then get compiler errors that tell you when you stray outside the bounds of the Windows runtime type system.
Those 4 rules, right?
Those 4 rules, exactly. And beyond that, Visual Studio also knows that once you've changed your project to be a Windows runtime project, JavaScript and C++ projects in the same solution or other ones can now start adding direct project-to-project references from that language to your new component. So it really, really makes it easy to use your new component from whatever project or whatever language you want. Now, I've just told you a whole bunch of stuff. I think I should actually prove it to you, because all I've done so far is show you code on a slide. And of course, run a tool that my team built 6 months ago. or updated 6 months ago. So let's, jumping ahead too much.
Yep.
What I'm going to do now is I'm going to build from scratch, no snippets, no precompiled code, nothing else.
That's code for no executive-style approach to building demo apps, I'd like to point out.
That's right. I've always not been a fan of code snippets, and so I won't be showing you any. Although we seem to not be projecting. Oh, there we go.
Projecting, I think.
So this is a blank window of Visual Studio. The first thing we're going to do is go to New Project, and we are going to start out with a JavaScript application. My project's UI is going to look a lot fancier than Harry's.
You're cheating. You're using the template.
Yeah, just because I'm using a fancier template. I don't know anything about UI design either.
A couple of type system plumbers walk into a bar. No.
We will be walking into a bar sometime after this. So we've got our default project template from JavaScript. It's a grid application. You've seen this a dozen times before in all 3 languages, so I'm not going to run it yet. The first thing we're going to do is we're going to customize the page title. And rather than have the app title be hard-coded, we're going to get that from a C# Windows Runtime component. So we go over to Solution Explorer, and we simply add a new project to this existing solution. We'll go over to C# and create a class library. Well, now we've created a .NET class library, but what we really want to do is we want this to be a WinMD, WinRT component rather than a .NET Framework DLL. And so all the magical steps involved in that, going to Project Properties, and you simply change your output type from class library to WinMD. Just as before, you could have changed it from DLL to XE. And you're done. With that step, Visual Studio now knows that you're building a Windows Runtime component and is now going to help guide you on that way. So the first thing we do, we follow one of the rules we talked about earlier. We are not building a XAML control, so we need to seal this class. And now we can add our members and go about our business. Let's add a single property, app name. Give it a getter.
I think the branding police will tell you you're supposed to use app, not application.
Sorry about that. Oh, is that right?
Yeah, that's right too. Yeah.
Excellent, excellent. So, with Harry's guidance on the branding, we have created our first Windows Runtime component in C#. And as I showed you, system, 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 and no attributes in the entire project. Very easy. But I haven't actually used it, so let's actually use it now. We'll add a reference to it from JavaScript directly to our project. You might notice that in none of these tabs you see a .NET Framework references dialog box. That's because they're all added automatically. But you still do need to add your references to your own projects. So now we've got it ready to use, so let's actually use it. We'll go to the fragment load page. And if this doesn't make sense to a lot of people in this audience, please bear with me. It didn't make sense to me a few months ago. I've had to learn JavaScript very recently.
Dynamic languages rock.
Former DLR team member. So let's get the page title.
And this is just standard JavaScript code here, right? It's query selector is just a standard. You just keep going, dude.
Okay.
The standard, we're just going to go get that DOM element that holds the title.
And now we have the DOM element, and we have the text content property that we want to set. Now we simply need to figure out a way to call into our class library from our JavaScript code. Oh, there it is. IntelliSense is already populated with your component. And it knows about this property that you just added.
Now you'll notice here that the title of this property is app name lowercase a, right? Where when we wrote it in C#, it was uppercase a. And that's on purpose. For JavaScript developers, natural and familiar is to use camel casing for methods that are not designed to be used with the new operator. New is very different in the JavaScript world than it is for you guys in C# and VB. So we automatically do that, that adaptation in the JavaScript projection. All Windows Runtime APIs, the standard design guideline is to use Pascal casing like .NET, but then when we project that into JavaScript, we automatically change it to camel casing so that it feels natural and familiar for them.
So the demo wizards are not being kind to me today. I am not getting any compiler errors. Instead, I am just not compiling.
It's JavaScript. You don't have to compile it.
OK, well, let's see what happens when we just hit F5 then. Yeah, it doesn't like that.
Oh, OK.
Oh, there we go. Deploy succeeded.
There you go.
There you go. You have your JavaScript application that has been done its UI in JavaScript and HTML, but calls into a C# Windows Runtime component for part of its functionality. And except for the explanation and the little hiccup in the build step, that took about 2 minutes. So very easy to do. In neither of the languages did you do anything that feels unfamiliar to you. You just wrote the code you'd expect to write, and everything just worked. So let's go back and let's do something a little more interesting here. Let's expand this project a bit and create a way to customize the groups that are shown in the group view. So what we're going to do, just in the interest of time, is customize the name of each group and make the number of items in that group appropriate for that group. And so we'll simply add those types to our class library project. Now, to shake things up a bit, I am going to use a struct rather than a class again, just to show you that. You make it public, and now you can add a few properties to it.
But you can't add any methods to it. Structs are plain old data in the Windows runtime, so you have to have pure data structures. No methods, no properties. It has to be just pure data.
That's right. And we'll call this people count. We'll have groups of people in this project. So now we've created our group class, or our group structure. We need to figure out a way to get a set of these back to the JavaScript app. So we'll go back to our original class, and we'll create a method here. And now I'm going to show you all the hoops you have to jump through to create a static method rather than an instance method. Actually, no, that wasn't so bad.
Wow, it's 6 whole new letters.
6 new letters. There we go. And we've used iListOfT in our signature, as we discussed earlier. Inside your method, you can, of course, still use listOfT. It's part of your implementation. It's not part of your signature. Let's add a few groups to this. And there are 2 of us.
Yeah, that's 2.
And how many people do you think are in here? I don't think we have enough time to count all of you all, so let's start with an estimate.
Well, there's at least 100 people in here.
At least 100? Do you think maybe 1,000?
Okay.
Yeah, I was going to round down to 37, but things have been going very well in this talk. And while I don't know what's going to happen when I choose 1,000, let's see what happens when I choose 1,000. And I really don't know. Harry doesn't know either. You're going to see the shocked face. If it doesn't work, he's going to be mad at me.
Hey, man, my demos worked without a hitch.
Oh. And there we go. We've now built it, and it is all set. It is now ready to use from JavaScript. And again, nothing unusual here. This is pretty much exactly the code you would write if you're creating a .NET Framework component that did the same.
Yeah, the only 2 things that we see here, it's got to be sealed, and you have to use iListOfT instead of listOfT. That is the only thing that Windows Runtime is making you do here in this code.
Exactly. Now, let's actually use this functionality. So we said what we're going to do is we're going to customize the groups. So let's go to the getGroups method. And you'll notice the IntelliSense has been filled out again. It knows immediately about our static. It knows we can access it without newing it up. And we are set. And if you look at my groups, you'll see that it does not look at anything like iList of t. This is the JavaScript version of a collection. And because just like we project Windows Runtime interfaces in a way that's natural and familiar to C# and VB developers, the JavaScript engine does the same thing. So you can use the normal JavaScript collection functionality. And in this case, we're going to use the JavaScript version of for each.
So this is just a standard JavaScript array when you're looking at this Windows Runtime collection type from JavaScript, even though it started life as a iList of t in managed code.
So we'll get rid of that hard-coded number of groups, and we're going to customize it to get the title from our class. And to use it later, we are going to store that group on that instance. Now, I have to admit that it is pretty cool that you can add a property to this instance just by assigning to it.
You know, if you use dynamic, you can do that in C# too.
Is that now your favorite keyword again?
No.
No, you still like await?
I like await a lot.
There we go.
I like them both.
And now we can close out that function, and we've customized our groups. Now it's time to customize the items. This will be easy as well. Rather than have a hard-coded formula for determining these, we're going to get it from that collection we just stored, the current group, group source, and again, a camel case property instead of a normal .NET Framework cased one. And that's it. We have just built a slightly more complicated version where the JavaScript and HTML UI is populating the standard default templates from a C# and Windows Runtime component with just a few lines of extra JavaScript code. Woohoo.
Hey, man, this is a touchscreen laptop, dude. You can do that. Oh, well, we went.
Oh.
Okay, so there we go. Look at that. 1,000, I'll tell you, that's the JavaScript engine that worked there with 1,000 components. That's cool.
That's pretty good.
Okay.
I don't have a touchscreen laptop. My team's not fancy enough for that. But
well, you guys are the ones who has the really cool touchscreen. I don't have that one either. This one is very clunky compared to that.
yes, you all are much cooler than us. That's why you all get your free tablets and we don't.
I'll push the button.
Yes. So with that, I'm going to pass the floor back over to Harry, and he's going to wrap things up for us.
Cool. So we just saw building a Windows Runtime component using just standard, natural and familiar. In fact, in that case, no Windows Runtime components or libraries or APIs or nothing, and being able to expose that directly to JavaScript in a natural and familiar way. I said at the top, you already know how to build these applications. I hope that you've seen through the course of this talk exactly how true that is. How the Windows Runtime design was influenced by C# and VB. The things that you know and love around a type system, around metadata, around design guidelines, and around XAML are core parts of the Windows Runtime. You saw how natural and familiar it is to use Windows Runtime. Almost everything is a direct mapping. Of the stuff that's remaining, there's a few things that you have to use extension methods for, but everything else is just, it's different under the hood, but as a C# developer, you just await, you just for each. You don't see any difference. And finally, we saw how you can build your own managed C# or VB components and expose them via the Windows Runtime infrastructure to JavaScript and C++ clients. There are a lot of talks on this content. I mentioned Plat 874 was Martin's talk, was just on, but it will be on video tomorrow if you haven't seen it. These slides will be available, so you'll be able to see all that. If you've got questions for us, we're going to be down in the expo hall at the platform booth, right?
Yep.
Platform booth.
.NET Framework and Visual Studio booth.
Apparently, we're going to be at the .NET Framework and Visual Studio booth to take your questions until well, I guess the attendee party's tonight, so until then. But we'll also be hanging out on the new Dev Center forums, forums.devcenter.windows.com. Please use the talk session ID, which is tool 531T. That'll get our attention. Also, if you get a chance, please fill out your session feedback, buildwin/session feedback. That's how we know that we're doing a good job and continue to do a great job going forward. Thank you for coming to this talk, and I hope you have a great time at Build.
Thank you.